everyone. This is Rajkumar D, Assistant Professor from Department of Information Technology, Dr. SNS Rajalakshmi College of Arts and Science. I welcome you all for this lecture in the subject data visualization. So today we are going to discuss about, in this video, we are going to discuss about frontiers of data visualization. What is data visualization? So data visualization is a representation of data through visual elements such as charts, graphs, and maps. Okay, so instead of representing a raw data for any stakeholders or a business plan or a decision-taking authority, we cannot just go and present the data as it is. So they need to have the grasp of data at a glance. So we will be employing a lot of techniques so that we are representing the entire data into a visual form which can be easily understood by them at a particular glance by providing all the necessary informations. So what actually data visualization do is it transforms the complex data sets into visual formats that the human brain can process more efficiently than raw numbers. Actually, this is the actual real purpose of data visualization. So here the graphical representation is going to be of both the quantitative and qualitative data. It also converts the abstract data into perceivable receivable forms. So it will be very easy to understand to make a better decision. It also enables the rapid pattern recognition and insight discovery to identify a different pattern for decision making authority, and it also helps us to facilitate the complex findings. So whatever is the trend or whatever is the new outliers or whatever it is we are going to identify it, we can easily communicate it into the diversible audiences. The audiences include all the stakeholders. Why this data visualization matters a lot. So it is going to be because the human visual system can process any information 60,000 times faster than a text whenever it is presented on images. So this is a massive impact of data visualization. It also leverages the capability to enhance and to understand the concept and make a better decision, and it also accelerates the data comprehension and data decision making process. It also helps us to identify the hidden trends, different correlations, and if at all we have any anomalies, it can also be easily detected and we can decide about it. It also improves the data retention, and actually it helps us to recall the memory whatever it is pre-stored to make a better decision. So next is the common chart types in data visualization. So this different chart types serve different purposes in especially in data exploration and the way it's getting communicated. So the selection depends upon the data type, whether it will be dimensional, it will be a dimensionality goal or it will be an analytical goal. The two important types are bar charts and heat maps. So the bar chart is used whenever we are using categorical data, and it helps us to show the difference in magnitude across the different categories. Next one is the heat maps. So the display displays the intensity patterns in 2D matrices, and it reveals the correlations and clustering. So it is widely useful in the time of COVID, and especially in the form of monsoons where we will be helping projecting to help the normal public about the amount of rainfall which is going to happen. So you can, this is a classic example of heat maps. Next is the core data visualization principles. So it involves five core principles. First one is clarity. Second one is the efficiency. Third one is the accuracy. Next comes the accessibility, and last comes the aesthetics. So clarity means it removes visual clutters and it emphasizes the data. The importance is given to data. Next one is efficiency, is to minimize the cognitive load of rapid comprehension. We have to easily communicate and efficiently communicate. Accuracy represents data truthfully without any distortion. Correct data has to be presented. And accessibility ensures to incorporate inclusive design for diversified users, because many types of users will be there. Last one is it should be visually appealing with different informational hierarchy, like using different colors, different images, and it should be an aesthetic one. Next one is the scientific data visualization. It helps us to visualize the physical phenomena, that is the molecule structures, the simulations and climatical data. So that is in the form of scientific visualizations. Next comes the information where we are going to show data structures, abstract data, networks, hierarchies. It also enables to discover the relationship in complex systems, and it supports hypothesis settings to prove or reject hypothesis, and it also facilitates advanced analytical exploration. Next comes the color theory. So color theory is to identify which colors and which have to be used, how it has to be used. So we are having color harmony. We should be using complementary, analogous, and triadiac schemes. And next comes the WCAG guidelines, which is a predefined set of guidelines regarding how to use the colors in visualization. And normally in the worldwide, we have 80% male affected with color blindness, and 0.5 female population is affected with color blindness. So who knows? They also may be in the group who is sitting in front of the presentation. So we have to consider them also. Next comes the sequential versus the categorical. We will be using different palettes matching the data types. Next comes the perceptual uniformity, where the color progression should match the data progression. So using the same color with different shades. This is how a data visualization pipeline is going to incorporate it. First comes the generation, next comes the collection of data, next the processing, storage, next is the management, analysis, visualization, and next is interpretation. If the interpretation is done differently, if there is a necessity for again go on to the same process, again we need to generate, and again we need to follow the same process. So this is how it is done. It is a systematic process that transforms the raw data into meaningful visual data representations through iterative refinements. So whenever there is a identify a problem in a particular step in the life cycle, we need to reiterate, and again we need to revalidate. So this is how an effective data representation can be generated. With this, we come to the end of this session. I hope this session was very useful for you. We will meet in the next session. Thank you.